Hello everybody, this is Eddie Ham with Alan Cho, and we are going to be teaching you about trigonometric equations. Our solution set is between 0 and 360 degrees. Our first example is 2 sine x minus 1 equals 0. The first thing you would have to do is add 1 to both sides of the equation. The 1s would cancel out, and you would then get 2 sine x equals 1. Then you would divide by 2 on each side, and then you would get that sine x equals 1/2. Raj. Now you would have to refer back to your unit circle, which will appear to the right, and then you would get that x equals 30 degrees or 150 degrees. Our second example is 2 tan x plus 2 radical 3. You would subtract 2 radical 3 on both sides of the equation, and you would get 2 tan x equals negative 2 radical 3. You divide both sides of the equation by 2, and then you would get tan x equal negative radical 3. Now, since it's negative, it will be in the second and fourth quadrant, and you would get that x equals 120 degrees or 300 degrees. Raj. We will now be dealing with more complex trigonometric equations. Our first example is sine squared x plus cosine x plus 1 equals 0. It is important to remember your trigonometric identities. Now, sine squared x is equal to 1 minus cosine squared x plus cosine x plus 1 equals 0. You would add the ones, and you would get negative cosine squared x plus cosine x plus 2 equaling 0. Now you would factor this and get 2 minus cosine x times 1 plus cosine x equals 0. Now let's work with the right side first. So 2 minus cosine x equals 0. You would add cosine x to both sides of the equation. You would then get that cosine x equals 2, but this is not a valid answer because cosine x could never equal 2. Now working with the left side, you get 1 plus cosine x equals 0. You'd subtract 1 on both sides of the equation, and you would get that cosine x equals negative 1. Now x equals 180. 180. Yeah. Raj, got that right, I know. It is very important to check your answer with the original equation. Now, okay, this went by a little bit too fast for me, so I'm just not gonna read it. But the end solutions are equal. And Raj, you did a very good job. I'm proud of you. Now, our second example is cosine x plus 1 equals sine x. You would square both sides, and you get cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. You would add cosine squared x to both sides, and subtract 1 on both sides. Both sides. Okay. 2 cosine squared x plus 2 cosine x equals 0. And then you would factor this and get 2 cosine x equals 0 and cosine x plus 1 equals 0. So cosine x equals 0, and then cosine x plus 1 equals 0. So then you subtract 1 on both sides and get that cosine x equals negative 1. Now the answers are 90 degrees, 180 degrees, or 270. Now you check these, and then as you watch the checking part of this, you'll see that 90 degrees works out and 180 degrees works out, but 270 doesn't work out. So yeah, so the answers are 90 and 180. We will now go over the area of a triangle. As you guys know, half base times height equals the area. What happens if you don't have the height? So height equals b times sine c. To the area equals 1/2 AB sine C.
Now we'll be going over the Euler's formula. It makes finding the area of a triangle much simpler in the case that you are only given the sides of the triangle. Now all you have to do for Euler's formula is times s by s minus a times s minus b times s minus c, and find the square root of that product. And s equals a plus b plus c divided by 2.
We will now go over the law of sine. The law of sine states that a over sine A equals b over sine b, which equals c over sine c. The law of cosine states that a squared equals b squared plus c squared minus 2bc cosine A. Now this is something you might have to think about, the ambiguous case. Now when two sides and an angle are included, SSA or ASS, also known as AS, are given, the triangle may not be unequally determined. This ambiguous case can only be used when the law of sine is used. So case 1, the acute triangles. 0 to 2 triangles can be formed. When you do when A is less than B sine A, 0 triangles. When A is equal to B sine A, 1 triangle. When B sine A is less than A, which is less than B, 2 triangles. When A is greater than or equal to B, there is only 1 triangle. Sometimes that case 2, when you get the obtuse triangles, so you get 0 to 1 triangles can be defined. A is less than or greater or equal to B, you get 0 triangles. When A is greater than B, you get 1 triangle. You see, like my chicken somebody. Chicken